Alright, this is my lab report for lab 2. These are my contents. Basically, we're measuring the magnetic field of a bar magnet at different locations. And we use data analysis to find some constants, and we visualize those magnetic fields using GlowScript. So the purpose of this lab is to become familiar with computing magnetic fields and to measure those magnetic fields with a phone app. And we also want to become familiar with using some data analysis tricks. These are the 4 principles in physics that I used. So first is just the relation between the distance and the between the observation location and the magnet with the magnetic field. And we take log on both sides, we get this. And this is the on-axis magnetic field formula for a magnet. And the 4th is for off-axis fields. So some preview of my results. I got the values for R, K, and mu as shown. And using GlowScript, I found that the magnetic field on the 45 degree is 2.8 10 to the power of -5. So this is my experimental setup for experiment 1. First, I found the chip location for the magnetic sensor, and then I found the distance where the magnetic field is 20 mu teslas. I did it for 5 different distances. The setup for second is I found the distance d-perp where the magnetic field is 100 mu teslas, and then I put it at a 45 degree, and I found the magnitude of the magnetic field at that location. So this is my results. You can see I got a straight line here, and the slope is r, and this is log of k. And also I found the magnetic field at the location. So these are my computations. I basically compared these 2 equations, and I found that n equals to this and k equals to this. And then I assumed that this r to the power of negative 0.0016 equals to 1, and I found mu. So some assumptions I made is that our magnet is a simple magnetic dipole, and n is small enough to neglect the effect of r. So basically I assumed that that thing is 1, and also that our phones have 0 thickness. So some questions. When it's far away, it does measure a near zero magnetic field. And when the magnetometer moves closer to the magnet, of course, the x component increases. This is my code. I coded this part, and I set the observation locations. And in this part, I basically drew some arrows to show how big the magnetic field is at the 45 degree location. So this is my result. You can see the magnitudes are correct and the directions are correct as well. This is the off-axis one. These are some numeric results, and I'll compare that with what I got with my experimental setup. You can see these 2 values are similar to each other, which says that my experiment is pretty accurate. Some additional questions. If we didn't compensate for magnetic north, then we would have to minus that, as in we did in setup 2. If we didn't, then our measurements would not be accurate. And secondly, if I had 2 identical magnets, since magnetic fields superpose, I would think that it would basically just make the magnitude larger. So basically, essentially, it's changing it into a stronger magnet, and nothing else would change. Some possible sources of error is that my app and device might not be accurate, and the chip, when locating the chip, I might not locate it correctly or accurately enough, and that we did not locate the z location. So basically, it's on the z-axis, it's not accurate. And we also assume that our environment is a uniform magnetic field, which it is not. It might be fluctuating. It might be changing all the time. And that is it, and thank you.